Hello and welcome, everyone. I appreciate your time today and joining us for this opMantic webinar on collecting non-SSH or Telnet device configurations. We have a pretty full house today on the GoToWebinar. For those of you that are here live, we will be following up with an email with a link to the video. For those of you who have found this training piece on opMantic's YouTube site or on our website, obviously you have access to the recording there. You'll also have access to a download in PDF format of today's presentation. For those of you here live, feel free to submit your questions anytime. You can use the GoToWebinar questions panel or the chat window, depending on which version of the GoToWebinar client that you have installed on your machine. If you're here live with the GoToWebinar piece, when you exit, so if you exit early or at the end of the webinar, you'll be presented with a very short exit survey, just 3 questions. Please take a moment and answer them. We appreciate your feedback greatly, and we use the information to help drive future webinar topics. So generally speaking, what we're going to be focusing on today, opConfig comes pre-built, pre-configured, with the ability to either SSH or Telnet to a device and then execute CLI commands based on the device's manufacturer, model, and operating system version number. So not every device, though, will respond to an SSH session or has a CLI interface. Many of them might have HTML interfaces, or they might have XML or JSON file formats that you can download to tell you how the device is performing at the moment. So what we've done, starting with opConfig 3.1.1, is we've added the ability to support plugin scripts. So what these allow you to do is to override opConfig's built-in SSH and CLI command collection routine, and instead specify a specific collection script. And then you can use that script to gather additional information, to do calculations, modify information, filter out content that you don't need, so you can remove things like passwords, etc., and also to be able to beautify or pretty up the display of information coming out of a command's configuration. And that's really what we're going to focus today's session on, is that concept. So just a very high level, I always like tying back each of these topics back to Gartner's IT Service Management Maturity Model. And from our perspective, when you start getting into command collection using opConfig, you're talking about being able to do problem management process, alerting, and event management. You're really looking at a very mature problem configuration change and asset management system, which helps, of course, move you further into a level 3 and level 4 as far as being an IT as a service provider, guaranteeing SLAs to your clients, whether those are internal business units or external customers. It allows you to integrate multiple processes together, especially if you're able to reach out to other solutions, other systems, and pull information. And of course, that can lead you towards more of a real-time infrastructure. So as far as today's seminar is concerned, you're really looking at 2 products from opMantic's product line. So you're looking at the core NMIS for performance and fault monitoring. And then you're also looking at opConfig, which is actually going to be able to reach out and do the collection of configurations and determine if there's been a change in configurations, raise alerts, etc. A few useful references for you. Again, for those of you who are joining us late, you can get a copy of this presentation in the GoToWebinar handouts panel as a PDF file. If you're coming into this presentation on YouTube or on opMantic's website, you should be able to find a copy of this presentation with that recording. So again, several useful references. We have the core homepage for the NMIS wiki and also for the opConfig wiki, as well as the plugins overview page in the wiki, which is a tremendous resource. Many of the examples we're going to go over today are included on that page as well. And of course, it goes into further detail than this webinar will, as far as how to raise alerts, and how to do some exceptional configurations in opConfig. In addition to opmantic's references, you can also find some great guidelines on configuration monitoring and configuration management from UC Berkeley's Secure Device Configuration Guideline, also from the Center for Internet Security, and from the U.S. National Security Agency Security Configuration Guidelines, which are now hosted on the IAD.gov website. All right, so let's talk a bit very quickly about how opConfig works and why you should use it. The first couple pieces really come from the UC Berkeley guidelines. The concept that configuration changes on covered devices should be logged automatically or via established change management processes. So you should be monitoring your device configurations, your network devices, your routers, switches, hubs, firewalls, load balancers, all those types of kind of traditional networking gear, but also you should be gathering configurations from your Windows devices and from your Linux type devices as well. And then custodians for those devices, whoever is responsible for monitoring those devices, should be alerted when configuration changes are made. And these, again, are both guidelines from UC Berkeley and from the IAD and from the NSA. So how does opConfig work? So the stock or standard methodology that opConfig uses is to use a set of credential sets along with a transport rule, so either SSH or Telnet, to connect to the device, and then execute, after logging in, execute a series of CLI commands, again, based on that device's manufacturer, model number, and operating system version. Execute the correct set of CLI devices for that device, pull that information back, and then compare that version of a command. So for example, show running startup, and then compare that command output to the last version that was stored. If there are no changes, then fine, just make a notation that the command is still good. And if there are differences, raise an alert if appropriate, and then also provide some visual cues, highlightings, notifications, email alerts, etc. Now, generally speaking, command collection is broken up into daily and hourly command collections. Those are both scheduled through cron jobs, so under etc/cron.d. There are additional commands that are available. They're called command tags. So these are groups of commands that can be executed. So for example, commands are marked for daily with the tag daily, the tag hourly, or the tag troubleshooting. And an individual command can have multiple different types of tags. So for example, you can actually tell opConfig, I want you to run all of the hourly troubleshooting commands right now, and it'll run all of those. Or you could say, I want you to run all the troubleshooting commands for this one specific device. And so based on that device's, again, manufacturer, model, operating system version number, it'll run the appropriate commands for that have a tag of troubleshooting or hourly or daily. A very high-level process overview, the concept of collecting commands. And again, this is going to be the same collecting commands, whether it's collecting commands that are pre-built in using SSH and CLI, command line interface, or whether it's running commands that are built as opConfig plugins. So the cron job runs, that starts the daily or the hourly command collection. opConfig executes the command collection. opConfig then compares the results of that collection against the last version for each command on each device. Events are generated if the commands are marked for event generation. And then NMIS, again, the core performance default monitoring solution, receives that change event from opConfig. And then NMIS can take automated response for that. opConfig also links the results of that event to that, or that change rather, to that event, so that NMIS and the users, the engineers responsible who are going to view that event, can see what changes have occurred that opConfig has identified. It's important to note that you can also expand NMIS's built-in escalation system with Opmantic's OP Events event management system as well, and actually take proactive response to those events. Very quickly, just a common workflow, starting with identification, devices, event elements, and priorities. So that's all handled again by opConfig and NMIS. Humans then investigate. Should these changes have occurred? They then add whatever comments and acknowledge the events or take action and remediation. And then following, determine why were configurations changed? Should we be alerting on these configuration changes? Should some kind of change management process been in place that would have dealt with these alerts before they were raised and humans had to be involved in making a determination? So again, that's the general process flow for opConfig, whether it's using the built-in SSH and CLI system or using opConfig plugins. So why use a plugin? Why expand on the existing system? Well, it really comes down to just a handful of concepts, really, right? Is that you want to be able to collect some kind of arbitrary data that is not available through the command line, and you want to be able to store it in relationship to that device or node. And you may even want to be able to compare it against previous versions of that data and alert on changes. You may even want to be able to simply take command output and be able to make it look better. And we're going to be taking a close look at an example of that today. You may want to run multiple commands, so you may want to pull data from multiple locations, compare the output of those commands, and then create a summary result from that and store that summary result. So you may want to do a complex calculation. And of course, the last thing, and this is a technical term, you might want to do some weird stuff. And in many cases, the weird stuff that we want to accomplish can only be done by or resolved by writing some kind of code. And this is where the plugin comes in. We also ran into a great example just a couple of weeks ago where a client had a series of pre-written collection routines that they already had in place now. And what they wanted to be able to do was repurpose that existing code base. And so working with opConfig, they were able to simply write a wrapper around that existing code base and then call that wrapper and have it call their existing code base, pull information back, store it in the main MongoDB, which is what opConfig uses as its backend, and then alert on those through the event management system. So that's the kind of weird stuff that I'm talking about. At the end of the day, there's really two different classes of opConfig plugins. Those are collecting device configurations. So you have one class that actually collects device configurations, and then you have a second class called processing that are used to filter and transform configuration data collection. It's important to understand that those two, while they sound very, very similar, are separate. Device configurations, collecting device configurations rather, is very focused and limited. You're only allowed to collect device configuration information. Generally speaking, you can do some manipulation, but you don't necessarily want to do a lot of filtering and transformation when you collect it. You want to collect the data and store it in its raw format and then process it. So it would become a two-step process. And again, we'll show an example of that today as well. All of your opConfig plugins have to be stored in the config_plugins directory. You can see the folder path if you use the default omk/config install path. And of course, there are specific rules and restrictions that apply. And these rules and restrictions apply to both configuration collection and configuration transformation. So all of your code, your plugins themselves, must be written in Perl. Now, an example I'm going to show you later today will show you a Perl wrapper that calls an external program. So you can take programs written in Python, Ruby on Rails, Bash, etc., and you can call them from a Perl wrapper that's very easy for you to repurpose and reuse. Plugins have to be named something.pm. You must include a package X line within the piece, and again, we'll show you examples of all this. The package name must not clash with any opconfig or NMIS components. So that's important. You cannot reuse an existing package name. It has to exist in its own memory space. The plugin itself must not use the Perl exporter to export anything from its namespace, and it must also not use the alarm function in Perl either. And as always, you should, of course, include a version declaration right after the package line. That's really in there just so you can help keep track of which version is being run, and so that opconfig can be aware of which version is there as well. So collection. So collecting data from a device. And again, this could be any kind of arbitrary data you want. So there are just a couple of quick steps here. The first step is you have to actually create your collection plugin. So you're going to create the .pm file, the Perl file, that will actually do the work itself of collecting the data. And remember, that could simply be a Perl wrapper that calls an external file. That's fine. In the commands delegation inside opconfig, rather than giving it a command to execute, so for example, rather than having a command like ps-ef, I would use the term external command for the command itself, and then I would say use collection plugin name, and I'd give it the plugin name for the name of it. Notice that the plugin name does not have the decimal or the extension to it, so I don't need .pm here at all. It's important to note that only one collection plugin can be assigned per command. You'll notice in a moment when we start talking about transformation commands that you can chain them together with a comma separation. That's only possible when you're using transformation or filtering commands, when you're actually processing the data from a command. But a collection command, you can only run one per command. And you also have to keep in mind that you must not modify any of the arguments passed into the command. So the transformation command, you can actually modify information passed into it and push that modified information back out. Or you can beautify it and then return the original result and send back the processed and modified content as well. But you cannot do that in a collection command. A collection command, you're going to run the collection command, gather your information, and then whatever you push back, you're only allowed to push back the results of that collection command. You're not allowed to change any of the arguments that are passed into a collection command. There are really only 4 acceptable outputs coming out of a collection command. That's going to be success, and that's either a 0 or a 1. You could have an error, so that's going to be some kind of an error message or a text message of an error that opconfig needs to be able to deal with. You can also ignore the results. So if ignore is 0, then the command is ignored and opconfig does not save anything. So you can actually execute a collection command that does something, but doesn't necessarily return any data back to opconfig. You might want it to do something and then take that information and pass it along to a filter. So that's possible as well. And then, of course, you'll have the configuration data itself. So it could be text or any other data format. So you could pass a hash, etc. But the configuration data literally is whatever is collected by that collection plugin and is being passed back. So let's take a quick look at what that might look like. So just a very, very basic sample here. And in fact, we've truncated and left out quite a bit of the preamble that begins this actual collection routine, and we've shortened a few of the pieces in here. But a couple of good examples here. First of all, you've got the subroutine collection configuration. So this is a requirement. The subroutine must be collect configuration. We're going to pull the arguments from the command line that are being passed to us. These are predefined. You do not have to process them. You do not have to use them. However, you should at least pull them in and be aware that they're available. Now, these are all also defined on that opconfig plugins wiki page. So each of these arguments are defined in detail. It talks about which ones are just plain text and which ones are hash references. One of the easiest thing to do is to use something like data dumper to pull all of the arguments and then push the information back to the screen just so you can see what it looks like. The next piece that we do, we're actually calling the built-in logger capability. So this is actually going to write back out to the opconfig log file for you. This is just an example very, very quickly about doing it just once to show that this command is being run. And it's important that you show that as your output going out into the log file. That way, if you're having to debug a sequence, you can at least see that this plugin was called and that the processing for this plugin started. You can, of course, include more than one logger line if you want to, no problem at all. And you can, of course, adjust the contents in the way that the line is laid out. Now, I spoke momentarily about the concept of a wrapper. So this is a good example of using a wrapper to call out to an external file. So in this case, we're calling out to user local bin complicated underscore operation. So I have no idea. Again, it's just an example of calling out to a file. Again, we could be calling out to a Python file. We could be calling out to another Perl routine. We could be calling out to a bash script. Anything that can be executed from the Linux server's command line, you can call out to. So think about the different operations that you might have there, right? You might want to write a script that connects to a SQL database and pulls information. You might write a script that connects to a web page and executes various commands, maybe logs into the web page, and then make sure that a very specific result page comes back. So there's a lot of different things that you can do with this. The sky is really the limit. It comes down to understanding what's the importance about the data. Can it already be done perhaps through a service monitor and NMIS? Could it be done directly through opconfig? Is a plugin really required? And if it is, understanding how to access the information you want and how to get it back in a format that is understandable by opconfig or can be modified and beautified by a transport plugin. So you'll see, for example, that we're opening a file. We're also saying, hey, if I can't open the file, we're going to go ahead and raise an error, fail to start complicated operation. We're going to take the results of that. So you can see here, for example, we're capturing the results of that, and then we're storing it in the variable goodies. Then we're closing that file, we're closing that connection, and then we're evaluating the results of that. So if no content came back, we're going to close that connection. And if we have good content, or we assume that we have some content, then we're going to return configuration data. So we're going to take that content, we're going to store it into configuration data. That's what we're going to return back to opconfig, and we're going to tell opconfig success. Yay. Please note that this file has to end with a true. So a number 1 followed by a colon. So if for some reason you'd skipped over every one of these return arguments and processing ended up at the bottom of the file, this will be evaluated as true, and it will exit this plugin. If for some reason processing gets to the bottom of this plugin and none of the returns have been executed, and there is no numeral 1 at the bottom of this file, then processing will stop inside opconfig. So if you're trying to troubleshoot what's going on with a broken or stalled plugin, this is probably where it's gone awry. So the last line in every single plugin, opConfig plugin, has to be the number 1, the numeral 1, followed by a semicolon. All right. Now, the second type of opConfig plugin is called a processing plugin. So you have a collection plugin that gathers information and then sends the resulting information into opConfig for storage, right, and evaluation. The processing plugin is designed specifically to do filtering and transformation of that configuration data. So, for example, you might use a collection plugin to gather information, right? So you might SCP a file from a remote location, locally open the file, read the file, and then store the contents of that file. And then you might execute a transformation processing plugin that opens that stored data, that retrieves that stored data from opConfig, that raw data, and does something with it. So you might actually process that content. So for example, we've got one here. So we're executing the command df-i, right? So a standard Linux command line, command. So we're pulling back information about the file system, and the -i argument says, oh, I want everything about the IO nodes on this device. And then we're going to take the results of that command, and we're going to run it through a plugin. So let's take a look, and we're going to take a look at a couple of different pieces here before we move on. So this is a little virtual router host. So this is a machine that we use for hosting routers on, little virtual routers for testing. And it's a little Linux machine. It's an older version. It's running 4.9. And what I want to be able to do is I want to still be able to execute commands against this machine. And one of the commands that we're executing is df, and we're also executing df-i. You can see that there's a whole host of other commands that we're executing against this machine, and we've got multiple different versions of those commands that we're storing. But let's take a quick look at one of these commands. So this one happens to be df-i. So you see at the top here, we have the raw command output. So this is what came back when we ran the df-i command on this device. So we got this information back. Now, this next block, this table at the bottom, what's labeled as derived information, this is what happened after we ran it through a processing script, so a processing plugin. So we've actually taken this information that's up here, we've broken out information that made sense to us, and we've stored it all down here at the bottom. So we're pulling different information out, and then we're doing some calculations that are here. We're reorganizing information into an order that makes sense. So for example, you can see that we've moved the file system to the center here. We have the mount point, which is normally the fifth column here, or sixth column rather. We've made the first column. And of course, now there's also built-in highlighting as well as we go through. So we can see information here. One of the other things that we can do with a processing filter is we can also raise events. So we could create errors, we can raise events both internally to opConfig. So for example, we can raise a configuration change event in opConfig, but we can also raise an event directly back to NMIS. So for example, if my usage exceeds a specific level, then I may want to raise an event, especially with inodes, because once you run out of inodes, you actually can't write to the file system. So you could raise events, you can do all kinds of different pieces. And let's take a look at what that actually looks like. So the first part of doing any kind of command, again, is you need to be able to link the command in with the command that you're using, or the plugin in rather with the command that you're using. So now this is one of my command files. This is the linux.nmis command file. And again, if we go back over here to PowerPoint, you can see, so for example, command delegation, this is all done in omk-conf command_sets.d, right? So it is a hidden directory, and the file we're looking at is linux.nmis. So back over to that file. And so there are two commands here that actually call the Linux command plugin, and you can see that here. Again, this is a processing plugin, not a collect plugin. We don't ship currently with any examples of collect plugins, but we do have several examples of processing plugins that'll show you some great formatting pieces that are in there. We're going to look at that today. So you can see that in these two commands, we have the command df and then the command df-i. And so let's take a look at what Linux command plugin does with the output. So again, back over to our example, this is the raw command output from the device. There is a little bit of formatting going on here, so there are tabs being added. And in the right-hand corner up here, you can see there's a button called raw text. So we can actually see exactly what the raw text looks like. But let's see what we come up with here for this derived information. And that's really where the power of this processing plugin comes in. So if I go over to the Linux command plugin, and I want to start at the top. So we have a package line. Again, remember, the package line is required. The package name needs to mimic the name of the plugin file itself. And it is case sensitive. So Linux command plugin, uppercase L, C, and P, has to manage the file name. And remember, the file name has to have the extension .pm on it. But the package name and the package name used here, again, also upper and lower case sensitive, all three of those have to match. Our version number, we're loading data dumper. That way we could do a little bit of debugging in this example file. And again, this ships, both of these files ship with opConfig. So when you download opConfig, you'll get samples of these files as well. They are used to execute these commands and beauty them up. So take a look at these as well. So sub process configuration. Again, you must use the subroutine name. We're expecting to find that subroutine name inside this plugin. We're loading the arguments from the command line. Now we're breaking those arguments out. We're assigning them to variables internally. We're executing that logger command, so we're actually logging this back to the opconfig log. We're creating a few variables for us to store information in. And then we're determining which command is being executed. Now, in this example, we're processing both the df and the df-h, or -i rather, inside the same command structure. But we could very well do an if-then-else waterfall. In fact, if we scroll down, you'll see here that our else said that we didn't find what we were looking for. So back to the top. So we're going to, again, create a few variables to store data in. We're then going to take that configuration data that got collected, either the df or the df-i output that got created originally by running the command and then stored for opconfig. We're going to take that configuration data that came in through the command line. We're going to break that up. So we're going to break that into individual lines. We're then going to skip blank lines. We're going to skip the line that starts with the file system. And you can see there's some stored examples that are here. We're then going to split the data on each tab. We're going to make sure that the data has 6 rows worth of information, or rather 6 columns, excuse me, worth of data. And then we're going to pull the columns of data and store them in variables locally. We're going to clean up the usage. We're going to look at a few different types of data, store some pieces here. We're going to set a threshold so we can create alarms later. We're going to, again, store some data in some variables, right? So we can raise an alert locally in opConfig, and then we can raise an event inside NMIS. Now, you'll notice that a big chunk of the next two if-then checks have been commented out. This is provided so that you can uncomment these if you want to raise events. We don't ship with these available right off, and that's simply because we don't want your system to be generating events where the threshold is hard-coded inside a plugin and perhaps difficult to find. So we want you to be aware that these are available here. And then underneath the else, if the threshold is cleared, you can clear the threshold and you can clear the event, and the examples here. So you can clear the event out and you can set it back to normal. And if there were no found conditions, then you can report back no issues identified with this command output, or you can report back the specific problem. So if the command doesn't run properly, you can actually, again, report back out any issues that you might have. Then we want to be able to beautify the information a bit. So we're giving it a descriptive title, file system usage in bytes, or if the command was df-i, file system usage by inodes. And so if we go back over and we take a look at what that looks like, you can see here file system usage by inodes. And if I look at the df output, which I have on this other tab here, you can see file system usage in bytes. So again, inside the plugin, we're taking the opportunity here inside the plugin to give it a title, to make it pretty. Now we're going to create a nice summary table here. Again, we're creating the format. We're making a type table, which is currently the current output supported by opConfig. You've got a mount point, type, and usage. You're assigning it a title. You're mapping out rows of data to it. And then we're sending the information out. All right. So that completes all of our information here. You can see again that we've got our derived info defined here. You can see our derived info there, as well as successes one, whether there are any alerts that need to go out, any conditions that need to be assigned to it, and the content. So we've taken a look at the Linux.nmis and the Linux command plugin. I do want to call your attention to one other. If you look at ios.nmis on line 281, we're actually using a plugin called High Bandwidth plugin to help modify the results of a show iOS top flow talkers. So it's a fantastic example of modifying, for example, information that's coming in hex and modifying it into decimal format for you, taking IP addresses and reformatting them so that they're viewable and human readable, and then organizing that information in a way that it outputs, again, in very much a formatted table structure, so it's much easier to read, it's highlightable, and it can be reorganized by things like highest bandwidth users, most data transmitted, most packets, etc. So there's a lot of opportunity in that example to look at ways of formatting information moving in and out of a command collection. Now, processing for coming in from a filter, again, you've got the opportunity to pass an error, your success, your configuration data, your derived information. You also have the additional pieces for alerts. So you can raise alerts from a processing plugin as well. And you can also raise additional conditions, both of which you cannot do from a collection plugin. And again, that's an important piece. So now you can always call a collection plugin and then use a processing plugin to process that information, make it look pretty, raise alerts, raise any other conditions that you need to from that processing plugin. All right, well, thank you all very much for your time today. That concludes our webinar on augmented collecting device configurations using non-SSH or Telnet and CLI options in opConfig. I hope that you found this of use, and I look forward to seeing you at a future webinar. Thank you.